types of bonds. So we continue with the same issue we started last time, the ionic bond and the molecular bond. So we said the ionic bond, it occurs by transferring or gaining electrons, between a metal and a non-metal. So the metal loses an electron, and the non-metal, it accepts the electron. Okay? So the metal loses or donates the electron, and the non-metal, it gains or accepts the electrons. Okay? So now they will turn into a positive ion and negative ion, like in the case of NaCl we discussed last time. The electron of the sodium moves to the chlorine, so it turns into positive and the chlorine turns into negative. The positive ion, we call it cation. Cat, like the cat. Cation. And the negative ion, we call it anion. Okay? So in chemistry, they call them cation and anion. If there is a positive ion or negative ion, so they attract each other and they form a bond. This bond is called ionic bond. It happens between metals and non-metals. Metals, usually they donate electrons. They try to lose electrons. They need to get rid of their electrons. Or we can say they are weak nuclei. Their nuclei are very weak, so they cannot hold the electrons. Anyone can steal the electrons from the metals. Not all of the metals, but many of them. Okay? Any non-metal can steal the electrons and pull them from them. Okay? So they form the ionic bond. In the picture here you can see another example between potassium and iodine. The potassium loses an electron for the iodine. The iodine takes this electron to complete the 8 electrons, which we call it octet rule. This rule, we call it octet rule, to complete the last shell with 8 electrons. So potassium becomes positive, which is a cation, and the chlorine, or this iodine here, it becomes a negative, which is an ion. So they form ionic bond. We call it Ki. Okay? Potassium iodide. Potassium iodide. This potassium iodide, it's always added with a very small percentage, like 0.05%, I think, or less. You can look at the box of the salt, you will find it actually. Okay, so less than, I think, 0.05%, it's added to the table salt, okay, to treat the iodine deficiency, because iodine is a vital element actually. We need it in our bodies, okay? Our brains, our nerves, I think, they need this iodine, okay? So if we have a deficiency, we might suffer from the thyroid, okay, or might suffer some intellectual problems. So the ionic bond is the force of attraction between two opposite charges, the cation and the anion, for the positive and negative ions. After losing and gaining electrons, the metal loses and the non-metal gains. Okay? So they form ionic compound. Okay? So the result of ionic bond is they form ionic compound. Give me example for the ionic compound in NaCl. Okay? Ki. Those previous examples. And here in this picture, MgCl2. The MgCl2, the magnesium chloride. Magnesium chloride. We have magnesium here. This magnesium has 2 electrons at the outmost level. It will lose it for the electrons. Or to be actually say it, the chlorine, it pulls the electrons from magnesium. Okay? It pulls the electrons from the magnesium. So magnesium magnesium turns into positive 2. It will turn into positive 2, and each chlorine becomes negative 1. So they cause the magnesium, Mg, chlorine, and we have 2 chlorines, so it's Cl2. So magnesium chloride. Okay? So that's also ionic compound. So we call them salts, by the way. Salts. أملاح. So salts are ionic compounds between a metal and non-metal. Okay. The second one is the covalent bond. Second one is the covalent bond, or we called it last time molecular bond. In the molecular bond or the covalent bond, no one of them loses electrons. And no one pulls the electrons totally from the other, because both are strong nuclei. They are able to pull their electrons. But sometimes one is stronger than the other. But both, they cannot lose their electrons. Okay? So the best scenario here is to share electrons between each other. So the best scenario is when they don't lose electrons is to share electrons. Okay? And we call it covalent bond. And the produced or the product here or the compound here, we call it a molecule. Okay? So what's the molecule? The molecule is the neutral particle that forms as a result of what? Sharing of electrons and forming this molecule. Okay? Like what? Like the water, H2O. Like the HCl. Let's start with the HCl, for example. H and Cl. Hydrogen has only one electron. Chlorine has 1, 2, 3, 4, 5, 6, 7. Okay? Hydrogen will not lose the electron. Chlorine also will not lose any of the electrons. So what is the best scenario here? Share the two electrons. Each one will share an electron. So they will form a covalent bond. This bond, we call it covalent bond or molecular bond, or sometimes we call it single molecular bond or single covalent bond, whatever you call it. Okay? So they share those two electrons. So the two electrons will move around the chlorine, and also they will move around the hydrogen. Al-Bara says, but H is stronger? No. H is not stronger. Chlorine is stronger than the hydrogen. The chlorine is stronger than the hydrogen, and I will tell you the property that tells you which one is stronger. Give me just few minutes. The second molecule is the molecule of water, and I think we discussed it last time. The oxygen has 1, 2, 3, 4, 5, and 6. And the hydrogen has only one. The other hydrogen has only one. Oxygen needs 2 electrons. So oxygen, if it doesn't find anybody to give it the electrons, it will search for the available, which is hydrogen in this case. Hydrogen is a strong atom. It cannot leave the electron. Oxygen also will not leave the electrons. Both of them, they pull their electrons. So the best scenario to make them stable is to share the electrons. So they will make 2 bonds. Okay? The first bond with the first hydrogen, the second bond with the second hydrogen. Okay? So if we look here on the right side, this is a bond, and this is another bond. So we have 2 bonds here. Okay? You understand this point or not? Guys, do you understand it? Okay, let's move to something else. Sometimes the covalent bond is single bond, like what we studied before, between H and Cl, that's a single bond. Between oxygen and hydrogen, that's a single bond. This one to the right is a single bond. And between oxygen and the other hydrogen, that's a single bond. So in the single bond, each element shares 1 electron. That's called single bond. And there is double or triple bond. In the double bond, they share 2 electrons between each other. And in the triple bond, they share, in the double bond, they share 2 electrons. And in the triple bond, they share 3 electrons. Like let's say this situation, between two oxygens. Oxygen is in the 16th column, so they have 6 electrons in the outmost level. They will do what? The best scenario here to do what? Of course, they will not lose electrons, but they will share it. So they will say, I will share this electron. Okay? And that makes it 7. So you will share another electron. That makes it 8. So now they share 2 electrons with each other. That's called, let's see, yeah, that's called double bond. That's called double bond. Okay? Let's see the case of nitrogen. Nitrogen in the 15th column. Oxygen is in the 16th. Nitrogen in the 15th column. So it has 5 electrons. So it needs 3 electrons to complete the level to 8 electrons and to complete the octet rule. So it will make what? Sharing 1 electron. Then sharing another electron. Then sharing 3rd electron. So they share 3 electrons with each other to complete 8 electrons. So in this case we call it triple bond. Triple bond. You might ask me, what about the carbon? Carbon is in the 14th column. Group number 14. Right? So carbon might share 4 electrons. Okay? But carbon, they might share the electrons in a single bond, or double bond, or triple bond. These are the allowed bonds. 1 or 2 or 3. Single or double or triple. Like in case of methane, the CH4, that's single bonds. We have four single bonds. Okay, CH4. Sometimes in some other hydrocarbons, we have a chain of carbons. Chain of carbon with hydrogen. And as you know, carbon loves hydrogen. Carbon loves the hydrogen. Okay, so that's a chain. This is a chain, silsila, of hydrocarbons. Of course, sometimes it's longer than that. Sometimes it's longer. So here, as you see, all of the bonds are single bonds. All of the bonds are single bonds. Sometimes, in some cases, in some molecules, maybe those hydrogens are cancelled and it will make double bond. So the carbon, double bond. The carbon will make double bond with the other, like this case. Okay. In some cases, let's say, give me a second. It will make triple bond, like this. Okay, it will make triple bond with 1 carbon. Like the graphite. Graphite is triple bond. Graphite, each carbon, is it triple bond? No, I don't think so. No, it's not triple bond. It's single bonds in graphite. I think so. It's not triple. But in this hydrocarbon, it's a triple bond. Okay? So it makes a triple bond with one of them and the 4th bond with anything else. It might be a carbon, might be a hydrogen, it might be whatever element that reacts with. Okay? So carbon might make single, double, or triple. The polarity. Polar and non-polar bonds. The bond itself might be polar or non-polar. Polar here means the bond has 2 sides. The bond has 2 sides. One of them is positive and one of them is negative. In this case, we call it polar bond. If the bond has a positive side and negative side, we call it polar bond. Give me example. Let's look at the first slide. Where is it? Yeah, this one. The NaCl or the Ki. Na becomes a positive ion and the chlorine becomes negative ion. So the bond in between, which is the ionic bond, we say it has high polarity. So ionic bonds in general, they have high polarity. The ionic bond has high polarity. Why the ionic bond has high polarity? Because it's in between a cation and an ion, a positive ion and a negative ion, between plus and minus. So it has polarity. Okay? So this bond is polarized. Okay? It's polarized. It has polarity, positive and negative. Ki also, it has polarity, positive and negative. Okay? But what about the covalent bond? The covalent bond, does it have polarity or not? Let's see. Sometimes yes, sometimes no. Sometimes the covalent bond is nonpolar. Sometimes the covalent bond is polar. What does it mean? Let's look at the nonpolar bond at the beginning. A covalent bond in which electrons are shared equally by two similar or identical atoms. In this case, we call it nonpolar bond. Again, when the covalent bond between two identical atoms or two similar atoms, similar in strength, like both of the atoms, they pull the electron with the same force or with the same amount. It's better to say the same amount. Okay? So we say that they are similar atoms. Okay? Or identical atoms, they are exactly the same. They are exactly the same. Like Abdullah says O2. That's right. O2, H2, N2, Cl2, whatever 2. Okay? These are nonpolar bonds. Because of what? Like in case of H2, for example, we have H and H. Each one has an electron, so they share the electrons to complete it to 2. So those 2 electrons, they will move for some amount around this hydrogen and for some amount around the other hydrogen. Both of the 2 hydrogen, they are identical. They are exactly the same. So they pull the electrons the same amount exactly. They pull the electrons the same amount exactly. In this case, the bond is called nonpolar bond. Nonpolar bond. It doesn't have polarity. No part is positive and no part is negative. Okay? Okay. Can you hear me now? Can you hear me? Guys? Okay, good. So if there is a problem, you might log out and log in. The other one is called the polar bond. The polar bond. I will try to talk slowly. The polar bond. It's the covalent bond in which electrons are shared unequally. The electrons are shared unequally by 2 non-identical atoms. And in this case, he means like one atom is stronger than the other in pulling the electrons. Okay? In pulling the shared electrons. One of them tries to pull the electrons more than the other. There is no justice here. Okay? The stronger pulls the electrons more. And that happens. Okay? And in this case, if one of them is pulling the electrons more than the other, we call this bond polar bond. And let's see why. Here in the HCl, hydrogen shares an electron, chlorine shares an electron. So those 2 electrons are shared between the chlorine and the hydrogen. Chlorine is stronger than hydrogen. Chlorine is stronger than hydrogen. So the chlorine will pull those electrons for most of the time. And the hydrogen will pull them for a very short time, comparing to the other time. So most of the time, the chlorine pulls, or the electrons, they move with the chlorine. And some of the time, or a little time they move with hydrogen. What's the result of this issue? Because the electrons they move around the chlorine most of the time, the chlorine turns into partially negative. So it becomes partially negative. We call it delta minus. And the hydrogen becomes partially positive. Partially positive. We call it delta plus. So in this molecule, part of the molecule is negative or slightly negative, and the other one is slightly positive relative to the other. Okay? So in this case, because we have positive part and negative part, or at least slightly positive and slightly negative, so this bond is polar bond. This bond is polar bond. Not very polar like the ionic bond. The ionic bond is highly polarized, okay? Because they are ions. But here it's a little bit less than the ions. And it depends. In some cases, the polarity is a little bit high. In some cases, the polarity is a little bit low. Some cases, as we said before, in the case of hydrogen or the case of oxygen, O2 and H2, there is no polarity at all. There is no polarity at all. You understand this point? The case of H2O, oxygen with hydrogen. They will share one electron with each other. The oxygen will share one electron with each hydrogen, and the hydrogen shares its electron. Oxygen is stronger than hydrogen. Oxygen is stronger than hydrogen. So the oxygen will pull those electrons for most of the time. Most of the time, oxygen will pull them, and some of the time, the hydrogen will pull them. So oxygen turns to be more negative, and hydrogen turns to be more positive. Also for the other hydrogen, with the other hydrogen, they share the other two electrons. So the oxygen will pull them, okay, most of the time, and the hydrogen will pull them a little bit less than oxygen. So oxygen in this bond turns to negative, and the hydrogen turns to positive. Delta plus and delta minus. Okay? So the two bonds here, those two bonds, we call them polar bonds. Polar bonds. Okay? So the bonds are polar. So this is a molecule of water, O, H, and H. We call them polar bonds. If the bond is polar, they form what we call dipole. Dipole. What's the meaning of dipole, guys? Dipole. Di means what? Di means what? Di means two. Di means two. Like two poles. Why do we have two poles? Because we have negative pole and positive pole. For each bond, there is a positive pole and negative pole. Okay? That's why they form what we call dipole. Dipole between H and Cl, it has a direction. It's a vector, actually. It's a vector. The dipole, or sometimes they call it dipole moment. Sometimes they call it dipole moment. Right. Let's go back to this issue. We said that when it is polar bond, okay, it forms a dipole. Okay, this dipole is a vector, and the vector has a direction from positive side to negative side. In the HCl, H is slightly positive and chlorine is slightly negative, so this is the direction of dipole. This arrow, I'm drawing it, this arrow is the direction of dipole. Okay? For the water, H and O, also H is a little bit positive, oxygen slightly negative, so we have two dipoles. We have two dipoles. This is the direction of the two dipoles. Okay, guys? So whenever there is a polar bond, that means there is a dipole from the positive side to the negative side. Let's see the polarity of the molecule. Sometimes the molecule itself is polarized. Sometimes the molecule is polarized. It might be polar or non-polar molecule. How is that? We said before there are dipoles. And these dipoles are vectors. These dipoles are vectors. Add, the rule says, add all the dipoles together. Add all the dipoles together as vectors. So the direction is very important here. So we will add all the dipole moments together. If the result is 0, if we find the result of addition is 0, so it's non-polar. Non-polar molecule. And if the result is not 0, so it's a polar molecule. Polar molecule. Again. So the molecule itself, like the molecule of water, the molecule of methane, the molecule of CO2, the molecule itself might be polar or non-polar. Okay? We add all the dipoles in the molecule together as vectors. If we find the result to be 0, it's non-polar. If the result is 0, it's non-polar. If the result is non-zero, so it's a polar. Okay? And also there are some violations. Like this is a general rule, but there are some violations. Let's try to apply this rule on the example that we see here. Carbon tetrachloride. Carbon tetrachloride. We have carbon. Carbon has 4 electrons in the outmost level. And if it has chlorines from everywhere, which one is stronger, guys? Chlorine or carbon? To know which one is stronger, we need to look at this property. Electronegativity. Electronegativity. الكهروسالبية. The one with higher electronegativity can pull the electrons more. And the one with lower electronegativity can pull the electrons less. Okay? Where is the lowest electronegativity here? Cesium. Where is the highest electronegativity here? Fluorine. Okay? So the electronegativity increases generally when you move to the right and also when you move upward. Okay? So the electronegativity increases in this direction. In this direction. Okay? There is a rule says what? The rule says what? The rule of electronegativity. And actually, it's not part of the curriculum of this year, but I will tell you about it. If the difference between the electronegativities of the two elements in a compound, if the difference is 2 or more, this compound is ionic compound and this bond is ionic bond. If the difference between two elements are 2 or more, the difference between the electronegativity of two elements is 2 or more, that's ionic bond. If the difference is 1.7 or less, that's covalent bond. Covalent bond. Okay? So, and that's also a general, general rule. There are some few violations. Okay? Some violations. But that's general. What if the difference is in between, from 1.7 up to 2? In this case, if the difference is more than or 1.7 or more and less than 2, the compound in this, we cannot say it's ionic or covalent, but sometimes it has it tends to be more ionic, and sometimes it tends to be more covalent. It depends on, like we can take it case by case. But when it's very close to 2, when it's closer to 2, it becomes more ionic than to be covalent. And if it's closer to 1.7, it's more covalent than to be ionic. Okay, guys? So you can find this rule from the electronegativity. Also, there are violations. Also, there is something else. If the difference in electronegativity is 0.4 or less, and some books says 0.5, it depends, is 0.4 or less, the bond is nonpolar. They consider the bond or the covalent bond to be nonpolar bond. Okay? If the difference between is less than 0.4 or less than 0.5, they consider it nonpolar bond. And if it is higher than 0.5, up to the 1.7, they consider it polar bond. Polar bond. Give me examples. Sodium with chlorine. The difference is what? What's the difference in electronegativity? Sodium and chlorine. The difference is almost What's the difference, guys, here between the electronegativity of sodium and chlorine? Is almost 2.1. That's right, 2.1. So 2.1, that means it's ionic bond. Okay? Magnesium and chlorine, the magnesium chloride. Huh? What's the difference here? What's the difference between magnesium and chlorine? 1.8. So you cannot judge it and say it's ionic. And also you cannot judge it and say it's covalent. But after testing this bond, they found it to be ionic. Okay, they found the magnesium chloride to be ionic. Okay, beryllium. Take the beryllium with, let's say, chlorine. Beryllium with chlorine. What's the difference? The difference is what? 1.4. The difference is, so what do you think? Beryllium and chlorine, 1.4. So it's what? It's ionic or covalent? Covalent, that's right. So the beryllium, although the beryllium is a metal, and it's in the second column, but it makes covalent bond. Why it makes covalent bond? Because beryllium has strong nuclei. The strong here means what? The electrons are close to the nucleus. The electrons, they have two levels. The first level has 2 electrons, and the second level has 2 electrons. So the outmost electrons, they are close to the nucleus. Okay? So the nucleus is able to pull them. So it will not lose any of the electrons. That's why it can only share electrons. So although it's a metal, but it shares electrons. Okay, guys? So the beryllium is considered one of the metals that makes covalent bonds, not ionic bonds. Okay? So anyway, we were talking about what? The chlorine and the carbon. Carbon and chlorine. Which one is stronger? Which one has more electronegativity? Chlorine has more electronegativity. It has 3, while the carbon has 2.5. Okay? So the chlorine becomes more negative. And the carbon becomes more positive. More positive. So here we do four dipoles. and the direction is from negative, from positive to the negative. 4 dipoles from the carbon to the chlorine. So I would write here, we have 4 single polar covalent bonds. We have 4 single polar covalent bonds. Okay, guys? What about the molecule? What about the molecule? Is it polar molecule or non-polar molecule? I said what? One of the methods is to add all the dipoles together. Add all the dipoles together and find the result. What's the result of adding all the dipoles together? 0, right? Because the right one will cancel the left one, and the upper one will cancel the down one, so the total is 0. So this molecule is non-polar molecule. Non-polar molecule. Okay, guys? Understand it? Huh? Let's see the other example. Trichloromethane. Trichloromethane. The trichloromethane is similar to the carbon tetrachloride. You don't need to remember the names. But one of the bonds is replaced by a hydrogen. So we have 3 chlorines and 1 hydrogen. The bonds or the dipoles of the chlorine stays the same. But what about the dipole with the hydrogen? Carbon is stronger than hydrogen. Carbon is stronger than hydrogen. So what will happen? Carbon becomes slightly negative, hydrogen becomes slightly positive, so the dipole becomes to the right, from the positive to the negative. So here we have also 4 single polar bonds. 4 single polar bonds. But what about the molecule itself? What about the molecule? Try to add all the dipoles together. The upper one cancels the down one, but those horizontal dipoles, they will be added to each other. So the net dipole moment or the net dipole is to the left. That means the molecule is polar molecule. This dipole or this molecule is polar molecule. Let's see those 2 examples before we are done. The CO2 and the H2O. Okay. In the CO2, we have double bonds. Carbon makes double bond with each oxygen. Oxygen shares 2 electrons and the carbon shares 2 electrons. And as you know, carbon needs 4, so it will use 2 oxygens. Okay, so here oxygen is stronger. Oxygen, as you see here, is 3.5, carbon is 2.5. Oxygen is stronger, so oxygen becomes a little bit negative, carbon becomes a little bit positive. So here we have 2 dipoles. Dipole to the right and dipole opposite to the left. So we have 2 double polar covalent bonds. We have 2 double polar covalent bonds. What about the dipole, guys? Sorry, what about the molecule? The molecule itself. Is it polar molecule or non-polar molecule? Non-polar, that's right. Non-polar. Non-polar. Because one dipole to the right and similar dipole to the left, they will cancel each other. So the molecule is non-polar molecule. Okay? Let's look at water. This is the shape of the molecule of water. And by the way, it has an angle. There is an angle between the two sides of the bonds. This angle, it's measured to be around 104 or 104.5 degree. Okay, this is the angle. We don't need the angle here, like we are not going to study. Anyway, so we said there are here between oxygen is stronger than hydrogen because it has higher electronegativity. So we have two dipoles. Let me show it to you in another color. We have two dipoles, one from hydrogen to oxygen and the other from hydrogen to oxygen. So here we have two single polar bonds. Two polar bonds. What about the molecule? Add the two dipoles together. Add the two dipoles. What's the result? When you add the two dipoles together and take care that they have an angle in between. They are not opposite. They are not opposite, but there is an angle in between. So the result will be what? Consider them like the forces. Do you remember the forces in physics? So add them like you add forces. So the result will be a net, we'll say force, but dipole moment or net dipole upward. So the result is net dipole upward. So the water molecule is polar molecule. That's why water is one of the highest polarized molecules. Okay, one of the highest polarized molecules. That's why water is an excellent solvent for salts. Salts. You know, salts are ionic bonds. Salts, they are ionic compounds. So they are polarized. They have positive and negative. Okay? And the polarized compounds, they are dissolved in polar molecule solute. Okay? So you can dissolve salt in water. And also, the non-polar, they are dissolved in the non-polar molecules. The non-polar, they are dissolved in the non-polar. And the polar, they are dissolved in the polar. Okay? While the non-polar, they cannot be dissolved in the polar. The non-polar, like the CO2, it cannot be dissolved in a polar substance like water. Okay? Like, we are not going to study this issue in our curriculum, but it's like general knowledge. Consider it general knowledge. Also, because water is polarized, it has minus and plus. Plus part, or let's say slightly plus and slightly minus. So these polarized compounds or these polarized molecules, they have a response to the electromagnetic waves. They respond to the electromagnetic waves. Like, for example, when you put some water in the microwave, it heats the water up. Why? Because water is a polar molecule. It has positive and negative sides. Slightly positive and negative sides. Because of this polarity, the molecule of water will start to shake, with the microwave. So you give it kinetic energy. And by collision and friction between the molecules of water, they transfer this energy to each other so you can heat up the water. If the water is non-polarized, you cannot see salt dissolved in water, and all of us will die. All of us will die. Why all of us will die? Because we will find no salt in the water. One of the important sources of salts that are essential to our bodies, we get it from the water. The water that we drink every day is not a pure water. It's not H2O only. It's a pure water, and inside it there are dissolved salts. Why it's dissolved? Because water is a polar molecule, and salts also are polar because they are what? They are polar because they are ionic compounds, so they have polarities. Okay, you will not see any oceans with salt. Oceans and sea will be with no salt. All the salt will settle down at the bottom of the oceans and at the bottom of the seas. They will not dissolve in the water. Okay? You cannot heat up the water with a microwave. You will not be able if the water is not a polar molecule. Do you understand these issues, guys? So, thank you for coming, and that's everything today.